We will discuss addressing. This chapter includes IPv4 addressing, address space, classful addressing, subnet mask, fixed length subnet mask FLSM, classless addressing, variable length subnet mask VLSM, network address translation NAT, supernetting, network devices, hub, repeaters, switch, bridge, and router. First, we will discuss about IPv4 addresses. Internet Protocol version 4 address. Generally, IPv4 is the version 4 Internet Protocol address. IP addresses are used to uniquely identify the particular device in the network. This is the unique address. Generally, we are calling this as the IP addresses. So if your device has two connections to the internet via two different networks, it has two IPv4 addresses. Address space. Address space is the total number of addresses used by the protocol. If your protocol uses B bits to define an address, the address space is 2 power B because each bit can have two different values, binary values, zeros and ones. IPv4 uses 32-bit address, which means that the address spaces is 2 power 32, that is more than 4 billion. So by using IPv4 addresses, we have an total number of addresses is more than 4 billions. Notation of the IP addresses. There are three types of notations to represent the Internet Protocol address. First one is the binary notation. The base is 2. Second one is dotted decimal notation DDN. And third one is hexadecimal notations. Its base is 16. So in binary notation, we can have a total of 32 bits. Each and every block is divided into 8 bits. We have 4 block of 8 bits, totally 32 bits. In case of dotted decimal notation DDN, that 4 blocks are represented in terms of decimal numbers. Hexadecimal, again that 4 blocks are represented in terms of hexadecimal number system. Hierarchy in addressing. A 32-bit IPv4 address is also called the hierarchical, but divided only into two parts. So the entire IP address is divided into two parts. The first part is always known as prefixes that define the network, and the second part is known as suffix that defines the node, that is the connection of the device to the internet. So the prefix always refers to the net ID and the suffix defines the host ID. Totally we have 32 bits. So n bits are used to represent the prefix, that is the network ID, and the remaining 32 minus n bits are used to represent the suffix, that is the host ID. Classful addressing. The whole address spaces was divided into 5 classes which are named as Class A, Class B, Class C, Class D and Class E. So totally 32 bits are used to represent the IPv4 address. So the address spaces is more than a 4 billion number of addresses we can represent by using IPv4. So class A, its prefix is n bits, and the first byte it starts from 0 to 127. So the first 8 bits are used to represent the prefix, that is the network ID, and the remaining 24 bits are used to represent the suffix, that is the host ID. In class B, first 16 bits are used to represent the prefix, that is net ID, and the remaining 16 bits are used to represent the suffix, that is the host ID. So in class B, the n value, that is prefix, is 16 bits. So its ranges from 128 to 191. These are the IP address ranges under class B. Class C, its prefix is, that is n is equal to 24 bits for network ID, and the remaining 8 bits are used to represent the host ID. So class C, n is equal to 24 bits, and the address ranges from 192 to 223. So the IP addresses, it starts from 192 and ends with 223. And class D, this kind of the class D addresses are mainly used for multicast address. Here we don't have a separate prefix part and the suffix part. There is no such a two divisions, that is prefix division, suffix division, that is not available in multicast addresses. So class D, no prefix, no suffix. So the IP addresses starts, the range is from 224 to 239, and class E, it is reserved for future use, and it is not used currently, and it is used for future use. And the IP addresses, the range is from 240 to 255. So these are the classful addressing. Currently 50% of the class A addresses are used, and 20% or 25% of class B addresses are used, and class C 12.5%, and class D 2.25% addresses are allocated for class D, and remaining 2.25% for class E. Class A can be assigned to only 128 organizations in the world, but each organization needs to have a single network. Class B addresses were designed for mid-size organizations, but many of the addresses in this class also remain unused. Class C addresses have a completely different flaw in design. The number of addresses that can be used in each network was so small that most companies were not comfortable using a block in this address class. And class D is always used for multicasting, and class E addresses were almost never used, so wasting the whole classes. In classful addressing, a large part of the available addresses were waste. Classful addressing, which is most obsolete, and it is replaced currently with the classless addressing. So this is one of the problem based questions. So the students are requested to uh, convert the given binary notation to the dotted decimal notations. These are the two questions. So how can you solve this kinds of the problem? Means you have to find the a decimal equivalent of each and every binary numbers. So this IP addresses are into 4 parts. So this is the first part, this is the second part, this is part 1, and this is part 2, and this is part 3, and this is part 4. So you have to find the decimal equivalent of this 4 parts. Then you will get the IPv address in dotted decimal notations. So we replace each group of 8 bits with its equivalent decimal number and add the dots for separation between the each parts. And this is the another problem. The given IP address, IPv4 addresses are in the dotted decimal notations. You are requested to convert into a binary format. So the solution for this kind of the problem is you have to replace each decimal number with its equivalent binary number. So decimal to binary conversions, that process you have to follow it and convert the given IP addresses into a binary format. So in this case of the questions, you have to, the students are requested to identify the error in the given IP addresses. 4 IP addresses are given. In the first IP address, 111.56.045.78. So the error in this kind of the IP addresses, there must be no leading zeros. In the third part of the address, it is 0445. IP addresses should not considers any leading zeros in each and every part, so it is not valid IP address. And the second IP address 221.34.7.8.20. So there are no more than 4 numbers. Actually you have only 4 parts. each and every parts are separated by a dot. So in this second B question, this IP address consists the 5 parts, so it is not valid one. And the third one, 75.45.301.14. So this is also not valid. The reason is each number needs to be less than or equal to 255. So the each and every part, actually 4 parts are there. Each and every parts, the maximum number is 255. 301 is not a valid one. So it is invalid IP address. And the last D questions, 111.00010.23.14.67. This is also invalid. A mixture of binary notation and the dotted decimal notation is not allowed. Either you have to represent the IP address in terms of binary notation or a dotted decimal notation. So the combination of both for a single IP address is not valid. Next concept is subnetting and supernetting. To, to alleviate address depletions, two strategies were proposed and to some extent implemented with the help of the two concepts subnetting and supernetting. In subnetting, a class A or class B block is divided into a several subnet. Each subnet has a larger prefix length than the original network. For example, if a network in class A is divided into 4 subnets, each subnet has a prefix of subnet length n sub is equal to 10. Subnetting was devised to divide a larger block into a smaller ones. Supernetting is the opposite concept of subnet. Supernetting was devised to combine several class C blocks into a larger block. Advantage of classful addressing. Although classful addressing had several problems and became obsolete, it had one advantage. Given an address, we can easily find the class of the address, and since the prefix length for each class is fixed, we can find the prefix length immediately. In other words, the prefix length in classful addressing is inherent in the address. No extra information is needed to extract the prefix and the suffix. So in classful address, immediately we can identify the prefix length. Classless addressing. In classless addressing, variable length blocks are used that belong to no classes. We can have a prefix length that ranges from 0 to 32. The size of the network is inversely proportional to the length of the prefix. A small prefix means a larger network. A larger prefix means a smaller network. So variable length blocks in classless addressing. So the address space that is divided into a n number of blocks. Each and every blocks can have a different length. This is the variable length blocks. Block 1, the given address, in case of IPv4, we can have more than 4 billion number of addresses. So entire address is divided into a number of blocks. Each and every blocks can have a variable length. This is the variable length blocks in classless addressing. Prefix length or slash notations. The prefix length that is denoted in terms of small n is added to the address separated by a slash. So in a given IP address, we are going to include a prefix length with the help of slash notations. The notation is informally referred to as slash notation and formally as classless interdomain routing, that is CIDR. So we have 4 parts of IP address. Each and every part is represented by using 8 bits, that is 1 byte, and these parts are separated by a dot. So at the end of the IP address, IPv4 address, we are using the slash. Then we have to specify the prefix length, that is n. For example, the IP address 12.24.76.8/n/8. That means the prefix length n is equal to 8. Another IP address 220.8.24.255/25. Here the prefix length n is equal to 25. Extracting information from an address. So you can extract the important information in classless addressing. So totally in IPv4 we have 32 bits. So the prefix is represented n by n bits, and 32 minus n bit, that is the suffix. So the prefix, that is the first address, and it consists, each and every prefix, it consists the first address and the last address. So the number of addresses here, capital N is equal to 2 power 32 minus n, because in IPv4 the size of the 32 bits are used to represent the IPv4 addresses. So 2 power 32 minus n, that is the capital N. Capital N indicates the total number of addresses. So the number of addresses in the block is found as capital N is equal to 2 power 32 minus small n, where small n is equal to prefix length. To find the first address, we keep the n leftmost bits and set the 32 minus n rightmost bits all to 0. So for a given IPv address, given /n notations, the students are requested to find the first address. So how can you find the first address means, you can know the n value, that is the prefix length. So you have to keep the leftmost n bits and set the 32 minus n rightmost bit, all bits to 0. So this is the first address in this address block. To find the last address, we have to keep the n leftmost bit as it is and set the 32 minus n rightmost all bits to ones. So if you apply this formulas, this methodologies, you can find the first address and the last address. So first address means left n bits you have to keep as it is, and the rightmost 32 minus n bits all should be set to 0. This is the first address. To find the last address, you have to keep the leftmost bits as it is and set the 32 minus n rightmost bits all to 1. This is the last address. Next concept is the address mask. The address mask is the 32-bit number in which the n leftmost bits are set to ones and the rest of the bits 32 minus n are set to the zeros. This is the address mask. That is, for a given 32-bit address, n leftmost bits are set to 1 and the remaining 32 minus n rightmost bits are set to 0. A computer can easily find the address mask because it is the complement of 2 power 32 minus n minus 1. The reason for defining a mask in this way is that it can be used by a computer program to extract the information in a block using the 3 bitwise operations, that is NOT, AND and OR. So the number of addresses in the block capital N is equal to NOT of mask plus 1. The first address in the block is equal to any addresses in the block, and you have to perform the AND operation with the mask. The last addresses in the block is equal to any addresses in the block and OR operations and NOT of mask. So mask, I already told you how to find the mask for a 32-bit number means you have to keep the n leftmost bits all set to 1 and the remaining 32 minus n rightmost bit all set to 0. This is the way to find the address mask. So subnet mask. So this is one of the easiest way to find the IP addresses. So 8-bit octet chart. So it starts from 2 power 0, 1, 2 power 1, 2, 2 power 2, 4, 2 cube 8, 2 power 4, 16, 2 power 5, 32, 2 power 6, 64, 2 power 7, 128. So totally you can have 8 bits. So this is the, if the given IP address is in the form of binary, if you want to convert into a dotted decimal notations, immediately you can do it. For example, if you want to find the IP address for the given DDN notation, that is 192.168.1.0. So this is the 8-bit octet chart, is the common chart. So first you have to identify by adding which bits. So you have to start from left to right, 192. So 192 can be obtained with the help of adding 128 plus 64. Then you will get what? 192. So this is the combination. Suppose if you want to get the 162, this is the 168, this is the next bit, means you have to consider the first 128. Then if you add the next 64, means your resultant will be more than 168. So you have to leave it 64. Then consider the 32. So 128 plus 32. Now you can have 160. Then you need 8 more values. So you have to go directly pick up the 8. So now you will get 168. So those bits 128, 32, 8. These bits only set to ones and the other remaining bits set to 0. Like that you can get the binary equivalent of the given DDN notation, that is decimal addresses. This is one of the example. A classless address is given as 167.199.170.82/27. So we can find the above 3 pieces of informations as follows. The first one is the number of addresses in the network. So the total number of addresses in the network, capital N, this you have to find out. What is the formula for finding the capital N? Capital N is equal to 2 power 32 minus small n. Small n is equal to prefix length. Prefix length is after slash you can have some number, that is the prefix length. So capital N is equal to 2 power 32 minus small n. Small n is the prefix length. This can be found with the help of slash notation. So slash 27. So small n is equal to 27 in this case. So 2 power 32 minus 27, you can have 2 power 5, that is equal to 32 addresses. So in this given address, the total number of addresses in this address is 32. Suppose if you want to find the first addresses in this given block, then what you have to do? You have to keep the n leftmost prefix as it is, and you have to set the 32 minus n rightmost bits to 0. So how can you do this one? So first convert the given IPv4 address into a binary form. You can use the previous 8-byte octet form to convert the given IP address into a binary form. So this is the example, 167.199.170.82. So its equivalent binary notation is 101001111, 11001111, 10101010, 01010010. So this is your first given IP address, and n prefixes small n value. So the first address in this block. So what you have to do? You have to keep the n. N means now n is equal to prefix length is equal to 27. So you have to start from leftmost 27 bits as it is. So which one is leftmost 27 bits? This is the first 8 bits, and this is the first 8 bits. Next 8 bits, 8 plus 8 16. Again this 8 24, and this 3 bits, 24 plus 3 27. So in this given IP address, this 27 bits should be as it is, and the remaining how many bits are there? Totally 32. The remaining bits are 5 bits. So that you have to set to 0. Now all the remaining 5 bits that are set to zeros in order to find the first address in this block. So this is the first address. And the next question is what? You have to find the last address in this block. What is the procedure? You have to keep the n, that is the prefix length is 27. So the 27 bits in the given IP address as it is, and the rightmost 32 minus n, 32 minus 27 is equal to 5. That 5 bits should be set to 1. So this is the last address in this case. So I hope that you can understand how to find the first address and the last address for the given IP addresses. So this is the procedure. First you have to find the total number of addresses in this network. How can you find the total number of addresses? The formula is capital N is equal to 2 power 32 minus small n. So small n is the prefix length. So this can be obtained with the help of after slash small n. So in this case 2 power 32 minus small n value is 27. So 32 minus 27, 5. Choose 2 power 5, that is equivalent to 32. So 32 address is the total number of addresses in this network. So first address, you have to keep the leftmost n bits as it is, and the remaining rightmost 32 minus n bits to set to 0. This is the first address. To find the last address in this block, keep the leftmost n bits as it is, and the remaining rightmost 32 minus n bits all set to 1. This is the last address. This is the previous one is the one kind of the method, and this is the another method to find the total number of addresses and first address and the last address in this range. A classless address is given, again 167.199.170.82/27. The mask in dotted decimal notation is, so the dotted decimal notation for this block is 256.256.256.224. The and, or and not operations you can perform for the individual bytes. So the total number of addresses in the block capital N is equal to not of mask. Mask already you can find it, and plus 1. So you will get 32 number of addresses. The same example we are taking here, and convert using the different methodologies. We are going to find the total number of address, first address and the last address. So the first address is equal to the address, the given IP address, and the mask. You have to apply the AND operation between the given IP address and the mask. You will get the first address and the last address. That address not of mask, you have to apply the not operation in that mask, given mask. Then address or operation not mask, you will get the last address in this address space. So these are the two different types of methodologies to find the total number of addresses in the block, first address and the last address in the block. So this is the another example. An ISP is granted the block 16.12.64.0/20. The ISP needs to allocate addresses for 8 organizations, each with 256 addresses. Find the number and range of addresses in the ISP block. This is the first question. Second one is find the range of addresses for each organizations and the range of unallocated addresses. Show the outline of the address distribution and the forwarding table. So first in this example, you have to find out the necessary informations. So initially you know that the total number of address formula capital N is equal to 2 power 32 minus small n, where small n is equal to prefix length. That is after slash you can have some numbers, that is the prefix length. So in this case the small n value is equal to 20. So the total number of addresses capital N is equal to 2 power 32 minus 20. You can have 2 power 12. That number of addresses is your total number of addresses.